Welcome back to everyone. My name is Giorgio Calculli. I'm in charge of training and member relations area of ACIMIT, that is the Association of Italian Textile Machinery Manufacturers. Here we are for the last webinar on Italian textile technologies. Let me thank our friend at National Textile University for helping us to successfully complete our webinars. We started 1 month ago, as some of you can remember. In ACIMIT, we are confident that there will be other opportunities for a win-win collaboration in the future. So thank you all again for coming. As you probably know, today's focus is on technologies for finishing. There will be 4 company presentations involved in this field. We are going to listen to the representative of Pozzi Leopoldo, Tecnorama, Guarneri Technology, and MS Printing Solutions. As the previous one, this webinar is recorded and will be given to National Textile University. Anyone wishing to ask questions can post them in the chat room, and the answer will be at the end of today's 4 presentation. So let's go quickly to the first panelist from Pozzi Leopoldo Company, Mr. Pier Lorenzo Bowen. Mr. Pier Lorenzo Bowen is a mechanical engineer that has worked in Pozzi since 2011. Firstly, in the technical and R&D department, and is now the manager of Pozzi's heat exchanger department. Please, Mr. Bowen, you are kindly requested to take the floor.
Thank you. Thank you. And thank you for everyone joining this presentation. So obviously, I work for Pozzi Leopoldo, and I'm here to present REX, which is our patented technology specifically designed to recover heat from dirty and troublesome fluids. Now, Pozzi is a company that has been founded in 1885, 135 years ago. And our business has always revolved around textile machines, building machinery for textile industry, and mainly in the wet processing of textiles. Now, in the last 30, 40 years, there has been a big shift in focus also towards producing energy recovery solutions.
There is some problem with your microphone.
Oh, can you hear me? Can you hear me?
Yes, now yes.
Yeah, maybe I was too far away. I'll stay closer. So as I was saying, Pozzi's focus has always been around textile machinery in the wet processing in textile. Now, we have reshaped our focus around 30 years ago, as well as making textile machinery, also creating solutions for energy recovery in textile industry. Now, this became very important because there was a big energy crisis, and it became apparent that a solution was needed for industry in general, but specifically to textile because of the nature of the effluents, which are mechanically and chemically polluted. There needs to be a different solution. Now, our success in heat recovery in textiles has allowed us to also broaden our horizons outside of the industry, of the textile industry, into also other environments, such as food industry, tank cleaning, latex, ceramics, and many other applications. Now, obviously, why are heat exchangers important? Well, in industrial environments, obviously, if you're able to save energy, you're able to save money. And similarly, if you're able to save energy, you're also able to reduce the amount of CO2 you're releasing in the environment. So 2 big and important aspects of heat exchanging and heat recovery. Now, to give you some idea of the impact, so a medium-sized Pozzi heat exchanger can produce savings in excess of 4 gigawatts. Now, this is equivalent to 400,000 standard meter cubes of natural gas, or 800 tons of CO2 emissions in 1 year. Now, consider that to counteract 800 tons of CO2 in a year, you will need to plant 1,100 trees. So if you then consider that we have installed more than 5,500 units, you can get an idea of how we are impacting positively the environment. Secondly, 4 gigawatt of energy are equivalent to roughly 100,000 euros of energy spent in a year. So not only, as I said before, not only a good environmental impact, but as well a big monetary saving for the end user. Now, why is there a need for a different exchange? Well, as I said, industry needs energy efficiency. And in cases like in textile wet processing, you have a lot of chemical agents acting in your effluent. You can think of dyes, or you can think of, for example, soap if you're doing washing, or bleach for bleaching, and things like that. But also, because of the nature of the materials you are treating in textile, you will always have fibers, filaments, or fluff present in your effluent. And if you use this type of discharges in a traditional heat exchanger, you will run into the problem called fouling as well as clogging. Now, briefly, an overview on traditional heat exchangers. You have, for example, the frame heat exchanger, or, for example, the plate heat exchanger and the shell and tube heat exchanger. Now, the basic concept behind these units, obviously they have some differences, but the base idea is to have a very thin passage for the fluids so that you can have, first of all, more surface area in contact with the ratio of fluid that is flowing, but as well, you're going to have a higher velocity. In thermodynamics, the velocity of the fluid is directly proportional to the heat exchanging coefficient and the heat exchanging efficiency that you're going to have. And when you're working with clean water, essentially, this works perfectly. But when you're working with dirty fluids, obviously you can already start to feel why this is a problem. A different type of solution is, for example, in coaxial heat exchangers, where they have a wider passage of area to allow for the bigger mechanical pollutants to pass through easily. The drawback of this is that obviously you're going to lose a lot of efficiency because, as I said before, velocity is directly proportional. Actually, it's the other way around. Efficiency is directly proportional to the velocity of the fluid. And so with a wider cross-sectional area, you're going to lose efficiency. And as well, you're going to run into the problem of fouling. Now, what is fouling and why is it a problem? Fouling is defined as the accumulation of unwanted material on the surfaces of a unit. In the case of heat exchangers, you can already imagine why this is a problem, because you're effectively putting an extra layer of material on top of your exchanging surface. And this material does not have the same properties as the metal that you're using for heat transfer. Now, these two pictures show this perfectly. In the top, you can see a plate from a plate heat exchanger, and in the bottom is the section of a shell and tube heat exchanger. In both cases, and these are pictures from textile environments, you can see that quite clearly all this accumulation of material is obviously going to hinder the use of the unit, because in case of fouling, just some, let's say, patina or film on the surface can easily lower drastically the efficiency of a unit. And in the case below, you can see a lot of the tubes in the shell and tube are actually clogged. And this will create issues because you're not using all those tubes, and you're obviously going to lose efficiency, as well as have a bigger pressure drop in your system. Now, this means that you will need to have maintenance for cleaning operations, which is a loss of time and obviously a loss of money. And as well, you're losing efficiency over time. So your starting efficiency is not going to be the same as your efficiency after 1 month or 2 weeks in some cases. Now, POTSI, as I said, has designed a completely different system. What we have decided to design was something that could easily work with all these mechanically and chemically polluted fluids without needing for any filtering systems, pumping systems, and having a low pressure drop on the clean water circuit. The idea was to have something that could work continuously with a high and constant efficiency without needing an external cleaning system. So the basic concept was to create effectively a discharge channel, which inside of it has an exchanging element. In our case, it's a rotating element, and I'll explain in a bit why rotation is so important. But the basic principle is as such. The rotor is constantly in rotation, and inside of it, the clean water is flowing. Now, inside each disc, there is a baffle, and we are forcing the clean water to go all over the surfaces, both surfaces of each disc. Now, obviously, the clean water, we are not worried about creating clogs or any issues as such. So the cross-sectional area is actually better if it's smaller. While outside, as I mentioned before, we want to have a much wider passage because this will not create issues with clogging and fouling and things like that. As well, we are putting baffles in between each disc, so we are forcing the dirty water to use as much as the surface as possible to create a more efficient system. Now, the rotation is extremely important because it gives us a lot of benefits. Firstly, the turbulence that we create in the water makes it so that all the mechanical components will stay in suspension in the effluent. This means that what comes in effectively will go out without depositing on the bottom of the unit. You need to remember that in our case, the exchanger is gravity fed. This is extremely important for continuous applications, such as, for example, washing after printing. You usually have a discharge, which is from an overflow. So it's already gravity. And if we have, and if we have a gravity fed system, it means that we do not need to have, we do not need to have a pumping system. Now, the second benefit of the turbulence is the fact that we are raising velocity. As I mentioned before already a number of times, the efficiency is directly proportional to the velocity that you're giving. So if you're raising the Reynolds number of the fluid, then you're raising efficiency. Another benefit is the fact that the centrifugal forces acting on the disc make it so that it is much more difficult for anything to get stuck to it. Now, the entirety of the heat exchanger is made in 316L stainless steel. It is particularly important in industrial environments because firstly, it gives us a more durable solution and as well a higher resistance to corrosion. In textile industry, you very well know that you use a big range of chemicals. And so we need to be able to be resistant to all of those agents. Obviously, if you were to use, for example, copper, you would create a much more efficient solution. But copper is not easily workable as stainless steel. We need to create also a pressure resistant system. And if I were to use copper and have a pressure rating of even just 3 bar, I would need to create something extremely thick, and it would not be as efficient anymore because the thickness of it will counteract the natural exchanging properties of the metal. Another thing that is worth noticing is that the rotor itself is electropolished. This is an electrochemical process which is done on stainless steel to effectively render the surfaces much smoother. This means that when you're dealing with chemical agents that would normally create patinas or films on the surfaces, you're actually rendering that much more difficult. The creation of patinas is almost impossible on well electropolished stainless steel. Generally, the process works like this. You have your process, which could be, for example, dyeing or bleaching or mercerizing, whatever, and you're going to have a hot discharge. This discharge can go by gravity, so no requires for pumps and no requirement for any filtering station. And we'll go directly to the exchanger. Then you will not need any backwash or any external cleaning system for the exchanger, which will preheat your water and feed it back to the process. Now, in 2019, we have done an Horizon 2020 project with the European Union where we upgraded our design. And there were a number of big new improvements on our technology. Firstly, the pressure resistant is now up to 5 bars, while before it was only 3 bar. And now we have a more compact and modular design, as well as having a higher efficiency and a better self-feedback. Now, what I mean by modular design is that the rotor itself, it used to be welded together, and now it's in a gasketed system. This means that we are able not only to, in case it were required, to change a single disc instead of a full rotor, but also because we don't need space for welding anymore, we can put the discs closer together. So a more compact and a more efficient unit. Another very interesting feature of our new design is what we call the pushing action. Now, this is due because of the geometry that we've created on our discs, the new design. The way it works is because the two sides of the disc effectively act, one as a backwards blade impeller and the other one as a forwards blade impeller. This means that we are creating two different flow velocities on the two sides of the discs. Now, if you're familiar with aerodynamics in airplanes, in an aerofoil, you effectively give two different flow velocities to the air of the wing of an airplane. And this generates a differential pressure, which in airplanes means that you're creating lift. In our case, these two different flow velocities generate a pushing action, which is obviously directed towards the outlet of the exchanger. This is particularly useful when you are dealing with very dense and very viscous fluids. This is not necessarily related to textile, but it becomes extremely interesting in other environments, such, for example, in ceramics, where the fluid is extremely dense because it's 70% dirt and 30% water. Now, to show you what I've been saying all along, I'll show you this video. This is from a dye house in Pakistan, and this is one of our units that's been installed and not being cleaned for more than 9 months. Now, in a traditional heat exchanger, you will see here in the static part of the exchanger, this happens in our exchanger as well in the static part, is what I was mentioning is the fouling. Now, in our case, it's not important because the exchanging element is the rotor itself. We don't care about the static parts, but you can see what would happen inside any other traditional or static type of heat exchanger. In our case, the exchanging part is still clean. And this means that even after 9 months, even after 1 year, because you are able to maintain the exchanging element clean, you will have a constant efficiency. Now, to give you an estimation, with REX, with our technology, with a constant efficiency, it is much better than any other type of technology that, for example, even for a plate heat exchanger, which normally has always a higher efficiency. But because you are losing immediately efficiency because of the fouling and because of clogging, and you will need to stop and do maintenance on it, over time, our solution is always much better. Now, as I was mentioning before, there's two different, let's say, type of realities and installations that can be done. On continuous machines, it's extremely easy because you just need to connect the overflow of the machine to our unit, and the clean water line passes through the rotor and then feed it back to the machine, and you're done. In other cases, for discontinuous plants, for example, in dyeing plants that works in batches, you will need to create a collection pit where you collect all the different batches, all the discharges that come in batches, and then feed it continuously. In that case, you will need pumps, valves, you will need some level controls, but other than that, nothing is required. And in many countries, such as, for example, in Pakistan, where the cost of steam euros is roughly 15 euros per metric ton of steam, the payback on our units is usually quicker than 6 months. which is probably the shortest payback you can get on any type of textile machinery. Now, to give you some examples, I mentioned already textile finishing machines, for example, washing after printing or things like that. Continuous applications is extremely easy. I mentioned already, for example, dye houses, where we collect all the different drops from the machines and then treat them in a constant flow rate. Other applications that we work in, for example, is in industrial laundries. They have machines, they are screw washing machines that work. And so collect all this effluent, which is dirty and with a lot of grease and mechanical pollutants as well, and preheat the water for the new batch. Another example is in jeans finishing. The problem there is that they use a lot of sands and enzyme for the treating, for the finishing of jeans. Tanneries as well. They have a lot of small fibers that come out with the discharge. And then we start getting outside of textile. For example, in plastic recycling, after they do the trimming of the plastic, they do a washing. And you can imagine, for example, plastic bottles, they have the label. So there's glue, there's some paper, all of these things that are in the discharge in a normal heat exchanger wouldn't even be able to pass through it. We also work in food industry, for example, poultry, defeathering. Once they remove and clean, when they remove the feathers and clean the chicken, there will be all the guts, the feathers, some blood. And we work there. And in reality, we do the opposite because we pre-cool the water. And the chillers, as you can imagine, still consume energy to do the cooling. And we are saving energy on the cooling. Similar thing to tomato and nut peeling. My time is almost up, so I don't want to be too specific in my examples. We have also done systems for steel tempering plants where we cool down the quenching oil that is done for the tempering. Tank cleaning plants as well. It can be for food industry tanks. It can be also for petrochemical tanks. Well, in latex, it's something that we started to work over the last couple of years, and they have obviously a lot of enzymes and a lot of the latex itself that is discharged with the ceramics, which is a very different environment for us because we are actually preheating the raw material that they use for the process. And it's a very, very complex and difficult material to deal with because it's very dense and very viscous. Now, just to finish off my presentation, we have been recognized internationally, firstly by the Innovation Radar, which is part of the EU Commission, which has recognized us as a key innovator after our work on the Horizon 2020 project, as well as the Solar Impulse Foundation, which has recognized REX as one of the 1,000 innovations that are both good for the environment and for the end. Thank you very much for listening, and I will look at your questions at the end of the whole presentation. Thank you.
Okay. Thank you, Pier Lorenzo, for this interesting presentation. It's time for our second panelist. So let me introduce Mr. Lorenzo Marsiglio from Technorama. Mr. Lorenzo Marsiglio is the Technorama Sales Director. He manages the sales department and takes care of foreign markets, in particular those of Asia. Please, Lorenzo, stage is yours.
Thank you, Giorgio, for the presentation. Welcome to everybody. I'm Lorenzo Marsiglio of Technorama. Technorama supplies dye house laboratory systems to develop the right recipe for bulk dyeing machines. It means that our systems are used in the dye house laboratory to develop the right recipe in order to reduce any correction or redyeing in bulk production. This recipe is developed by our dose and die system, which consists in a automatic dispensing machine combined with one or more sampling die machines. So let me show you on detail our system. System is called dose and die. Dose and die means is acronyms of dosing and dyeing. It's two different parts in the same system. One is for dosing, dispensing of solutions of dye stuff, and one is the dyeing. Dyeing different kind of dyeing machines. So as I told you, the first part is dispensing is called dosorama. Dosorama is a multi-pipette dispensing system. Multi-pipette means that each solution of dye stuff has its own pipette. These avoid any kind of contaminations because the same pipette remain always with the same solutions. By a robotic hand, the system can pick up the pipette, dispense the solutions, and drop the pipette again. When we have to change solution, the robotic arm collects the other pipette and dispense the other solution. Solutions are automatically prepared by the system because in the same parking of solutions bottles, there is as well the dye stuff containers. By another robotic arm, these dye stuff containers are picked up and go into the automatic solution maker to prepare solution. This full automatic without any operator intervention. It means that the system itself collects the empty bottle, the clean bottle, place it on the scale, collect the dispensing canisters for powder dye stuff, dispense the right quantity, dispense water, mix, prepare the solution, and place it on stock. Once the solution is expired or finished, there is an automatic bottle washing station. So here again, operator is not needed. The machine itself collects the bottle, place in this bottle station, wash it, and keep it cleaned, ready for the next solution. By side, there is a basket to dispense these solutions for different beakers of laboratory manual machines as infrared, atmospheric, or open bath. But what is very important in the system is the dyeing part. Different kind of dyeing machines according to different form of the material. We can dye yarn, we can dye fabric, knitted fabric, as well fibers or tops. Different kind of dye machine, different size as well. Here is 500 grams. We have 100 grams or smaller 10, 20 grams. In case of yarn dyeing, our machines 100 and 500, they have a reversible pump, centrifugal reversible pump. This just to replicate in laboratory the right recipe of bulk, because bulk dye machines are working with a centrifugal reversible pump. The last machine developed by Technorama is a Shakerama. We already have in Pakistan 2 customers having the Shakerama and Dyrama machine. Shakerama is it was developed right for the knit fabric, because it reproduces the movement, the mechanical movement of the jet flow dye machines. Another robotic arm can collect can collect the material holders with the fabric or with the yarn. Collect, place in the dyeing gear, dispense dye stuff, dispense chemical, exactly the same recipe as bulk. The system is supplied with a water heater for to heat the water. It can be also supplied with a container for chemicals in case of salt and soda, of a large consumption of salt and soda. And apart, another device is dissolving unit used to dissolve dye stuff in powder forms and sent to external small batches dye machine as 1 kg, 2 kg, used as a samples or confirmation for buyers. So the right recipe is just to compare the recipe with this is the recipe that we used in our system. It started from scouring, bleaching, all single step of the bulk dyeing machines. So heating, dispensing of soda, dispensing of salt, after dyeing, draining, fill again, neutralization, draining, fill again for washing, soaping, hot water washing. So according to the bulk process. This just to compare to the manual laboratory, which has only all-in dispensing of all components in one time, loading of sample, dyeing, and the rest of operation are made manually by the operator. For this reason, we say that we developed the right recipe at the first time, because we process in laboratory exactly the same process as bulk. Another slide is the comparison for the full automatic dozen die comparing to the manual laboratory. With the manual laboratory, the recipe are developed by the operator, which goes to the confirmation die machines, come back because maybe at the first time they are not able to find the recipe for correction, again confirmation, then go to bulk. Maybe they have to go once again to confirmation for correction, and then finally to bulk. With a dozen die, you can go straight to bulk because the recipe is right first time. Now I show you as well some video of our systems. The first is the die machine Shekarama. Shekarama, as I told you, it was developed especially for knit fabric. So the operator has only to prepare the gray samples in the baskets, gray samples or material ready to dye. This is according to operator, because if the substrate is different each and every day, it is better to make as well scouring and bleaching here. Otherwise, if the substrate is always the same, we can use as well material ready to dye. Here we have the parking station with all solutions. So by this robotic arm, the solutions are collected and dispensed directly inside the dyeing gear. This is possible because the system is a high accuracy volumetric system. It means that we don't need any scale to check the quantity, because we know that the quantity is dispensed with accuracy of 0.01 cc. After preparing dyeing bath, there is a small cycle of dyeing bath circulation, just to mix all the components inside the beakers. And then after this operation, there is a sample loading. In this case as well, knit fabric, especially, this was developed especially for knit fabric, but it's possible to dye as well fabric, woven, knit, terry towels. All systems we have now in Pakistan are used to develop a recipe for terry towels. So system is working 24 hours a day, 7 days a week. Operators has only to prepare the gray samples and collect once done. When the cycle is finished, means that is completely finished. We don't need any other operation because washing, soaping, everything was already done by the system itself. In case of cotton, of reactive dyeing, it's possible to dispense as well soda and salt according to the carver. Here you have to remind that we are talking about samples. Samples means 5, 10, maybe 20 grams. So the alkali dispensing is really a small part. It means some drops only. but we are able to replicate the curve of alkali dispensing. Once the dyeing cycle is completely finished, the robotic arm download the sample and load the next for the next dyeing.
Lorenzo, ci sei?
Sì, sì, sono qui, volevo lasciare un po' vedere le immagini. Sorry, I just let the video go. Now I show you the same system, but used for yarn dye machine. So basically the concept is the same, dispensing machine connected this to another kind of dye machine. This dye machine is working with a reversible pump, centrifugal reversible pump. So again, preparation of the dye bath. As you see, the shape of the dyeing here is different. In the left part of the screen, you can see the machine for knit fabric working by itself. And here we are dispensing the solution for this 100 grams dye machine for yarn. Of course, the system is different according customer to customer. We have different number of rows of dye machines, different combination. Some customer that is manufacturing yarn only, of course, they will have only this kind of dye machine. But customer, as we have in Pakistan, manufacturing terry towels, they use both. They use the knit fabric machine for small pieces of terry towels, and the yarn because there is some embroidery in the same towel. As well, machine is supplied according customer request for the number of bottles and dye stuff containers, because these are according to the number of dye stuff used by the customer. So here you can see the drawing of double circulation, internal, external, external, internal, same as production dye machines. This is a smaller dye machine used for 10-20 grams only. In this case, there is not a centrifugal pump, it's a magnetic pump, it's a turbine, creating a flow only out in. Because for 20 grams, the thickness is not so big, so we can use only one circulation. Here as well, in case of reactive dyeing for cotton, it's possible to dispense salt and soda. Alkali dispensing according to the curve. So if we have 8 hours in production for the dyeing cycle, we have 8 hours here. The system is not used to reduce the length of the dyeing cycle. It's not used to reduce the time. Because if you want to develop the right recipe, you have to replicate it 100% in all the steps. Means in time and dispensing, as well the procedure. First, dyeing bed circulation, then sample loading, material loading, alkali dispensing, and all the last washing and soaping. These are small bobbins of 100 grams. Finally, last video is the solution maker, means how the machine prepared the solutions. So as you saw in the first presentation, we have a parking place for bottles and dye stuff. When one solution is finished or expired, usually the life of solution is 3, 4, maximum 5 days. So as well, if the bottle is still full because we didn't use this solution, the solution is expired, so needed to be replaced. The first operation is to collect the bottle, place it in the automatic washing bottle system, wash the pipette as well. Now that the bottle is cleaned, it's placed on the scale for calibration. This is the powder container. Once the quantity is reached on the scale, because to dispense powder, of course, the system is gravimetric, but solutions is volumetric. This is very important that solution is volumetric. Because we can dispense directly inside the dyeing gear without checking the weight, because we are sure about the dispense. Solution now is ready, is mixed, so it's placed in stock again, ready to be used. So this is the system, doesn't die, Technorama. In case you have some question at the end of the webinar, it will be my pleasure to answer. Grazie, Giorgio. Thank you to everybody.
Thanks to Lorenzo. Let's move on with the next panelist of today, Ettore Guarneri from Guarneri Technology. Ettore Guarneri is the CEO of Guarneri Technology. He leads the family business with his brother Alberto. Guarneri Technology is in cooperation with the German Voigt for the manufacturing of textiles and technical textile calendars equipped with NIPCO technology rollers. Please, Ettore.
Thank you very much, Giorgio. Thank you very much. Thank you very much, Giorgio. Thank you very much for everybody to join this webinar. We, Guarneri Technology, I am the third generation of the company. Started my grandfather, then my father, now me and my brother, we are leading the company. The fourth generation is already on the field. It means my two sons and my nephew are already involved in the company. And in 2004, we decided to have this cooperation with Voigt company. Voigt is a German company. And now I want to show you a presentation. Condividi? Okay, this is our motto is welcoming to the blue. And non va, Matteo. Okay, this just to give you some numbers about our cooperation with Voigt. Voigt and us, we are present in over 60 countries. The total number of employees is 19,000. And Voigt is family owned since 1867. The total turnover of Voigt is 4.2 billion. But all this number, I suppose that the number that we are very proud to show is the research and development ratio, that on the total turnover is 5.3%. It means that we are always in research and developing new system, because we have this NIPCO roller that is very famous in Pakistan, in order to control the deflection of the roller in the calendar. Calendar is a machine in order to finish, in order to give a very good result and good effect to the fabric. So in this case, due to the reason that we have from 2 to 5 rollers, one against the other in pressure, is important to control the deflection of the roller in order to give a perfect uniformity on the fabric. Of course, in order to make this big turnover, there are different fields like hydro, digital ventures, turbo, and paper. Imagine that concerning the calendar, on the textile, normally the roller width of the calendar is for shirting fabrics 2 meters, and for bed linen 3.4, 3.6 meters. In paper, everything changed, because, for example, the widest calendar that we manufacture for paper is 14 meters width, with a production speed of 2,500 meters per minute. So it's something totally out of the textile and technical textile market. Textile is a very interesting market in which we are present since the 60s. But in the last, let me say, 10, 15 years, also the technical textile market is very important. It's very important because some product that before was considered normal textile now becomes technical textile with the different performance in the fabric. For example, we have the NIPCO HT7 zone. It means that for fabric like parachute fabric or filtration or fabric for the sails, we have to control the perfect uniformity of fabric. What it means? It means that normally the fabric before the calendar arrive with some mistake in the fabric. It means that in the middle, the air permeability in the fabric is constant, but when we move in the edges, in the right and the left, this air permeability change. So in this case, if we calendar in a normal way, granting the uniformity of pressure, it means that we repeat the mistake. It means in the middle that I have, for example, 2,000 liters as a air permeability passage, we can reduce 1,000. But if in the edges we have 4,000, we can reduce from 4,000 to 2,000. It means that this mistake is repeated. This was the reason why we decided to develop the NIPCO 7 zone in 2 meters, where I can control the piston, each piston or zone or piston zone. It means, for example, as you can see now in the movie, in the video, we give a we give now, as you can see in the touch screen, we give a pressure in the edges, but not in the middle. So, perché si è fermato il video? There is some line problem. Matteo non va via. This is something good about live. No. Okay, now it seems that it's working. So as you can see, in the edges, no. I'm sorry, but anyway, the system is to have the possibility to control piston by piston, and with a special device made by Text Test Switzerland, we can control the air permeability. In case the air permeability in a certain part of the fabric is different, automatically we can correct the pressure only in that area. And this is important in order to obtain a final result with the air permeability more or less the same from right to left. Of course, this is for technical textile. We have different kind of NIPCO calendar. The NIPCO families, for example, is made by the NIPCO I, that is a two-roller. We are manufacturing the NIPCO system since 1978. And the pressure can be from 50 to 400 Newton millimeter in order to obtain different kind of finishing on the fabric. With the steel roller very hot, we can reach all the shining that we want, for example, for the winter jacket, where we need to control the air permeability, but we need also a very shining effect on this polyester fabric. We have also the NIPCO L, but the NIPCO L is the very fantastic machine for shirting fabric and bed linen fabric, where we need to create a softness on the fabric, because, you know, for the buyers that want to buy fabric, the first impact is the color or the printing, but the second is the softness of the fabric. If the fabric is well printed or is well dyed, everybody are happy, but then if the touch of the fabric is not very good, the fabric becomes not so interesting. It's our target to give this mechanical effect to the fabric in order to reach all the kind of softness or the kind of shining that we want. And with the NIPCO L, that is a calendar with 3 roller, we can reach all the degrees of softness that we want. We create also this NIPCO Multiflex that we call a Mickey Mouse. Is a 5-bolt calendar, and as you can see, we call a Mickey Mouse because we have this 2 horizontal steel roller, the NIPCO roller, and 2 cotton roller. Why we created this machine? This is the most expensive machine that we manufacture, but for some customer is a very interesting solution, because mainly on bed linen, sometimes the international buyer, they play with the price. It means that they contact several companies and they try to get the most attractive price. But of course, this is not a good way for a textile company to squeeze every day the price. So with this calendar, we can create a special effect, giving a very softness over the desire, but in the meantime create also a very elegant shining like the silk. Because normally in the calendar you give a flat shining like a mirror, but you know, on bed linen, on the shirting fabric, you don't need to have this kind of high shining. You need to have a very very gentle shining. It means that the shine is not flat, the shine is like a silk, and is something really appreciated by final user. This is a very big machine. As you can see, the proportion between the man and the calendar. This is the hydraulic unit in which we control the pressure. And then we have also developed some different cover. For example, this cover that is named Full Flex TT3 is a Duroplast material. And the surface, the hardness on the surface is more than the standard polyamide. And this is good in order to reach a certain air permeability on polyester material for filtration. Then we have also this cover that made in rubber. Also, this can be interesting, is very appreciated in the automotive. Automotive, I mean a company that produce the seat of the car. As you know, in the last year, they developed this 3D effect, 3D design, and a combination of the engraved steel roller against this NIPCO covered by rubber, we can weld the 3 layers, because normally the seat of the car is composed by polyester, 100% polyester on top. In the middle, we have the foam, and on the bottom, we have a knitting part. These three, in order to create this 3D effect, must be fixed and welded one against the other. And with the NIPCO, in which we can grant a perfect uniformity of pressure, and thanks to the composite rubber sleeve, we can reach this effect that normally is made not in inline, but is made by single part. And with this system, we are able to make the continuous production and not piece by piece. This is more or less this is more or less the production of Guarneri technology. As I told you, we are involved mainly in calendars, and we presented last year our dyeing powder because is a machine similar to the calendar, but we decided to develop this dyeing powder in order to create a very perfect control of the dyeing in fabric, in woven fabric, also in knitted fabric. So this is the presentation. We can talk. I can talk for hours and hours, but I think that what you want to know is at some point about what we produce, the high-tech calendar that we produce. I am anyway at your full disposal for any kind of question. It will be my pleasure to answer to all of you, and I thank you for the attention you gave me. Thank you very much.
Thank you, Ettore. It's time for our final panelist of today, Mr. Gianluca Bestetti from MS Printing Solutions. Mr. Gianluca Bestetti is Area Sales Manager of MS. He joined JK Group in 2007. From 2015, JK Group and MS Printing Solutions belong to the same group, Dover. His background started with screen printing inks, offset printing inks, photo emulsions, and textile digital inks. Please, Mr. Bestetti, you are kindly requested to take the floor.
Yes. Okay. Thanks, Mr. Giorgio, for your introduction. Thanks to everybody to be here today, and thanks for your time. So I am representing MS Printing Solution and JK Group. MS Printing Solution and JK Group belong to the same group, Dover Corporation. The headquarters of Dover Corporation is in the USA, in Chicago. And this company is involved in different types of businesses: energy, fluids, engineering system, and refrigerator. Here are some dates regarding the line time. So let's say that for us, it's important to underline that the project for digital for JK Group started in 1999, while for MS, always in 1999, when the first digital printing machine was studied. In 2014, Dover Corporation acquired MS Printing Solution, while in 2015, Dover Corporation acquires JK Group. Where we are located? We are located in the north of Italy, both for MS and JK. We are very close, just to let you understand, to Milano Malpensa airports. And we have offices in Novedrate and in Caronno. As I told you before, MS Printing Solution is producing textile industrial digital machine, and the main sector is, of course, digital printing. Just to give you an idea about the process during this year, let me share with you a short video regarding the really first machine approach at that time. So as you can see, at the time, the speed of the machine was up to 26 meters per minute. So, but later you will understand why I am showing you this video. So at the time was really the first approach, the first touch to digital printing, and of course during all these years, the process and the technology are completely different. The MS core competence is again to produce textile digital machine, but also steamers and electronic board. This is a very important point because we are really completely independent in the production of the electronic boards for all our machines. The technology for all MS printer is Kyocera technology, so Japanese technologies. Here you have some details regarding the printheads with which we equip all our machine. So why we are different from other competitor? Because, or better, why we decided to be focused on this technology? Because the printheads, as you can see, it's bigger than the other competitor. Because according to our evaluation, these printheads is strong, resistant, and reliable during the time. And of course, after all the controls that we did in the past, we noticed that there is a very high durability under stress conditions. With this slide, I would like to tell you that, of course, in our series, we have different models, and we will touch all these models later. But what we can assure is that with all our models, the customers maintaining for some size condition like same ink, same software, preparation, and the same printing mode, you can get always the same printing result. This means the same output. These are some pictures about our training center. So our training center is well equipped with all our models. And this is the location where we can say we share our know-how with all our customers and all our dealers. Let's say that all our customers and dealers can come there, share our experience, see the machine running, and of course also eventually do some trials. So talking about JK Group, which is the other company belonging to Dover Corporation, I can tell you that in this case, the focus is the production of textile digital inks. So in our portfolio, we have sublimation inks, both for direct printing and transfer printing. We have disperse inks, pigment inks, and reactive inks. One of the most important aspects regarding the JK Group is the production department. We have a completely dedicated production for all our types of ink. It's a unique production system because we projected from the beginning this everything, all the steps, all the machines, all the lines, etc. So for this reason, we can say that it's a unique production system. So the quality control is very strict. As you can see at the bottom of the slide, we have, let's say, 5 steps. And during all these 5 steps, we have a quality control. This means that, for example, we have an entrance when we receive the raw material, we check all the raw material. And after the approbation of the quality control, we move to the next step, which is mixing. And also in this case, we have a quality control. This means that before moving to the other step, the quality control department approves the batch. The same for the milling, the same for mixing dilution, and of course also the same for the purification and the gases process. The production capacity is around 3 million kilo per year. The milling method, of course, is nanodot technology, and the batch dimension can move from 50 kilo to 4 tons kilo. This is another slide to let you understand how the process has been changed during this year. So let's say that 10 years ago, to print 30 kilometers of fabric in digital was completely different. So you see that in 1999, to print 30 kilometers of fabric, you took 3 years. But nowadays, thanks to the fastest machine that we have in our pipeline, you take 8 hours. So completely different. Yes, digital printing, textile digital printing is still a growing market. Of course, last year was a little bit different for all the reasons that we know, but we can say that it's still growing, and fortunately, starting from this year again, we are seeing again a growing. So the percentage is around 20-25% more every year. And this is due to some key factors, of course, the machine speed, some brand requests, because nowadays very important brands are demanding for digital printing, the know-how, and of course the cost per meter, which is now more competitive. Another important factor for digital printing is that, for example, compared to traditional printing, the consumption of water is less, and this means that, for example, looking at the yellow square, we can give back 10 liters of water to every human being compared to traditional printing. So you have, let's say, a saving of 90%. Digital printing is also, compared to traditional and conventional printing, completely different. So you have some precise advantages, like sample, easy to produce, short run with low cost, no kitchen, color kitchen, no cylinder, no limitation in number of colors, and of course just-in-time production to satisfy the market request, which is nowadays very quick. Yes, here are some numbers. So again, water consumption with digital printing compared to conventional printing is reduced by 60%. Emission into water is reduced by 16%, electricity saving is reduced by 80%, and the reduction of CO2 is reduced by 40%. This is a big impact, positively, of course, for the environment. Here, I would like to show you just a study, research run by a technical research center of Finland. They compare the production of a batch of 650 square meter of fabric, 100% cotton, in reactive printing compared to traditional and digital. Here you can see that, of course, at the end of the story, you have a big reduction in terms of water and carbon dioxide. Because in each step during the printing, of course, in digital, it's you have a shorter process, you have a big saving. We can say that in digital, for this example, you use around 6.3629 liters compared to traditional, which is 17,000 liters. So 60% less water consumption. Again, this is just to summarize what I introduced you before. Water consumption 60% less, and CO2 emission is 40% less. MS is, and of course also JK, but in this case, this specific slide is for MS machine. It's let's say we have a green label, which is confirming that MS is, say it's a green equipment in the market. Here are some details regarding what we can offer in the market. So we start with this model, which is the name is JP4 model. This model is mainly in market for sublimation printing, for transfer printing. So you print on the paper and then you go to transfer by heat on white polyester fabric. So for all MS machines, there is a fixed resolution. But the most important point is that you can play with the drop size printed on the fabric or on the paper. So you can see that from 4 to 72 picoliter drop size. JP4 mainly is equipped with 4S or 8S Kyocera heads. This model is JP7. Normally, it's equipped with 16 Kyocera print heads, up to 8 colors. Of course, the speed is faster than JP4 model. And again, also here we have fixed printing resolution. Minimum resolution is 600 dpi by 600 dpi, and with the same feature for the in drop size. JPK Evo is equipped with 32 Kyocera print heads, and also here the speed is faster. So one pass printing, you can reach 580 meter per hour. So the size in this case can vary according to the customer demand, from 1.8 meter to 3.2 meter. So the application for normally, the application for this machine, for this printing, is for fashion, sportswear, home decoration, or soft signage. Okay, here just a short video for JP7. So the one equipped with the 16 Kyocera print. So you can see the machine moving. So at the bottom, in this case, you can see the fabric. So we are printing directly on the fabric. Of course, the machine normally are coming also with some important optional to let the fabric enter inside the machine, to let the fabric going out from the machine. Then, of course, according to the type of ink that you are printing, disperse, pigment, reactive, or sublimation, you have some other steps. Yeah. So let's say that the latest one that we have in our portfolio is Mini Lario. This machine is equipped with 64 Kyocera pre-nets, and you can see that the speed is up one pass 995 meters per hour. So the big monster, so the fastest machine and the biggest machine that we have in our portfolio is the Lario, and you can see the speed is 9,000 meters per hour. So it's a completely new innovation in the market. It's a single pass machine, and you can go up till more than 200 Kyocera pre-nets. I should have also here a video. This is a customer in Pakistan, and which was so kind to give us this video showing you the Lario. So you can see that it's for each each station it's one color. So in this case it's a single pass machine because as you can see the bar equipped with the Kyocera pre-nets is fixed, and the fabric it's coming down and it's printed by the heads. So you can see the speed of this machine. And yeah, we have already main installations worldwide. Of course, not only in Pakistan, but let's say that in Pakistan we have, of course, more than one machine more. Here, they wrote some details, just to let us see how the machine is working. Yes, last but not least, as I mentioned you at the beginning, so MS is also producing a steamer. It's a new concept steamer because in the past we were used to promote a completely different solution in the market. This steamer, it's a new concept because of, first of all, steamer, you have two different heating sources. So you can use an external steam boiler, or you can use an external diathermic oil boiler. Why is different? Because with MS steamer you can have a steam consumption reduced by 45% due to the innovative steam recirculation system equipped in the chamber. So you have no dispersion and you have a more careful control of the steam production. There is also the possibility, very important, because it's affecting your cost and it's affecting the final quality of the output, to have less need of urea for the preparation of the fabric. So you know that normally for the preparation of the fabric you need this chemical. And normally for traditional and conventional printing, you are called to use a big quantity of urea. But the target of the MS steamer is to have the possibility to use less urea due to some control, due to some systems inside the steamer. There is also a very important feature of the steamer, which is the variable roller steps. This can allow the customer to change the size of the roller steps in order to avoid the risk of color repetition between the layers of the printed fabric. Yes, last but very important, of course, as MS, we can also customize some financial support for all our customers. Let me also spend a few seconds to thanks also all our local contacts, Mr. Hamid, Mr. Khalid, and Mr. Abrar, who are supporting us a lot in this challenge. So for the moment, it's all. I will be more than pleased to answer all your questions. And for now, thanks to everybody. Thanks for this opportunity.
Thank you, Gianluca, for your presentation. I will ask our host, Dr. Javid, if he has collected or if he has any questions for our panelists.
Thank you, Mr. Giorgio. Can you hear me?
Yeah?
Can you hear me?
Yeah. I can.
I have few questions. First one is from Mr. Bowen. The presentation was very nice. That was about the heat exchangers. The question is that by using this type of the heat exchangers, as you have presented, how much energy or money we can save by using this type of heat exchanger?
Obviously, for any type of heat exchanger, it depends mainly on two factors: the flow rates of both fluids and the surface area that you're giving to your heat exchanger. To give you a rough estimation, let's say if you have 10 cubic meter per hour of discharge in a factory, which is generally speaking a small amount of water, with a small size exchanger, I can do the calculation actually really quickly. 10 cubic meter. In Pakistan, usually we have water around 30 degrees for fresh water. And let's say we are doing cotton dyeing, which we can expect 80 degrees Celsius on the discharge if we separate the drains, the hot and cold drains. In this case, we can have 391 kilowatt saved per hour. This, in, let's say, Pakistani value of money for the cost of steam is equivalent to 82,000 euros saved in 1 year. And this is with 10 metric cube. Obviously, if you have a bigger factory, because I've seen a lot of factories that maybe have 20 dyeing machines, and so you are already thinking of 100 meter cube per hour of discharge, then obviously it scales up. And this I'm using the smallest exchanger that I can use with 10 meter cube. So if I use a bigger exchanger, the efficiency goes up. Instead of 70%, I can get 90%, for example. So there's a lot of variables. It depends from case to case. But as I mentioned in the presentation, generally speaking, the payback is around 6 months. It means that if you're paying 50,000 euros for the exchangers, you are saving 100,000 euros in all. To give you a rough estimation.
Okay, thank you. Next question is from Mr. Marsilio. Mr. Marsilio presented his presentation on dispensing system.
Right.
Yeah. Is this a lab scale dispensing system, or it also works for the bulk production?
We also have dispensing system for bulk production, for dye stuff, liquid chemicals, solid chemicals. But the presentation of today was only for laboratory.
Okay, is there any customer, your customer in Pakistan for this dispensing system, where it is installed?
For lab or production? Production we have not. For laboratory we have International Textile and Al-Karam.
Okay.
If someone needs to see the machine in operation, you can contact our agent that you have in the information, Mustex company, which can arrange a visit in one of these customers.
Okay, thank you.
My pleasure.
Next question is from Mr. Gorneri, who presented on NIPCO technology. Yeah. Can you please elaborate in detail what are the advantages of NIPCO technology over the other application technologies?
Allora, as you know, the best calendar effort you reach if you have a perfect uniformity of pressure from right to left. The NIPCO can grant you, through the hydraulic piston inside, to have a same pressure from right to left, but not only. But with the NIPCO, due to the reason that we have inside physically the pistons, I can activate the piston depending the fabric width. It means that on a calendar, for example, 340 for bed linen, but in case I have to use 2 meters fabric width, I can activate just the piston on 2 meters wide. And the other thing is that not every day the customer has to use the same recipe. It means that for some fabric, maybe they need a medium pressure, or for other fabric, they need a maximum pressure. With an NIPCO system, I can play from 50 to 400 Newton per millimeter. It means from 20 tons up to 100 tons, depending the final effect that I want to do. It means that with the NIPCO system, you do not have any limitation. Depending your recipe, depending the final user, which kind of softness or brightness you want, we can set the machine according to the recipe that customer wants. The NIPCO grants you the perfect uniformity of pressure. Why? Because in the calendar, when you put the roller in pressure, there is a bending, there is a deflection of the roller. The NIPCO system was created in order to compensate and granting the perfect uniformity of pressure. Taking account that this system in 1973 was developed for paper industry, where we know that in the paper industry, the roller width is very wide. Imagine that the widest machine, the widest calendar that we produce for paper is 14 meters wide against 3.4 for bed linen.
Okay, thank you. So this system is very efficient for dyeing of fabric, where LCR is a major problem.
Absolutely.
Thank you. Okay, thank you. The next question is from Mr. Gianluca, who presented on digital printing. MS, they are marketing the machinery from the MS brand, who has presented MS Lario, that is about continuous printing machine. The question is that even if the high production rate of the MS Lario, is there any effect on quality of the print?
No, let's say that of course there are some differences if you compare traditional and conventional printing, but let's say that during this year the gap it's very close, and of course the process is completely different. So the big advantage of this machine, specifically Lario, is of course the speed of the machine, and we have already a system in Lario which can allow you also to have the preparation of the fabric in line. So let's say that at the end of the day, it's already present, but it's already a reality, and will be more and more in the future something that will change the market. So many companies are already aware about this possibility, and they are switching from traditional and conventional printing to digital printing. So let's say, to answer to your question, that the gap, let's say that we can say that it's not existing.
No, okay. So where is MS Lario installed in Pakistan?
Yes, in this case, I have shown you a video provided by Mekotex company, which is a very important company in Pakistan, and they have recently installed Lario. But of course, we have some other units running in Pakistan.
Okay. Okay, thank you, Mr. George. Over to you.
Okay, thank you all for your attention. I think we consider our webinars as over. Hopefully see you next time in Faisalabad for a live in-person event. We cross our fingers. And thank you all again. And bye-bye. Thank you.
Thank you.
Thank you.
Thank
Bye.
you, everybody. Bye.
Bye.
Thank you.
Thank you.
Thank you. Thank you.